everybody, and welcome to today's topic of linear law. So this is a linear equation. We've done this in coordinate geometry. Y and x are two variables which are drawn against each other in this diagram. They are related by this whole equation. M is the slope, which can be found using this formula. C is the y-intercept. That means that the place where the line cuts the y-axis is the y-intercept. So this is an equation. Two of the variables are related. Y is drawn against x. Okay, the thing which is against is on the x-axis, and the thing which is set first is always on the y-axis. So this was another formula to find out the C. So what is linear law? Linear law is that two variables are related regardless that they are linear or they are not. They are related by an equation and they form a straight line graph, a linear equation actually, and they have a slope and a y-intercept. Okay, now let's look at how to apply this linear law to non-linear equations. Okay, so we've been given a question and it says that we are given this equation. Now you can see that it is 1 upon y. It is not a polynomial, so it is a non-linear equation. Now you have to make this into linear law. So we can relate this that we can take 1 upon y as y, this y, and root x as x. Okay, so we can relate 1 upon y and root x through an equation in which a is the gradient and b is the y-intercept. So we take y as 1 upon y, x as root x, and we have to find the estimate of a and b, and we've been given the certain values of x for which y is this. So when x is 0.5, y is 1.61, when x is 1, y is 0.83, and so on. So we don't have the value of a, we don't have the value of b, and we have to find them through linear law by using this non-linear equation and plotting a linear graph of it. Okay, so how will we do this? Okay, so to solve this and to relate it to the equation, which was 1 upon y into a root x plus b. So instead of y, we have to put 1 upon y. So we will simply reciprocate all of these values and write the answer in the 1 upon y values. Okay, and now because we need root x instead of x, so we will root all of these values. We will root each and every one of them, and we'll put the answers in root x. Now we will assume this is y and this is x, and we will put it into the equation this. Alright, now once we plot this, we can find the y-intercept and we can find the gradient. So we put these points here. Now we can, because I've not drawn this on a graph, you will draw this on a graph which will be more accurate. So we can find the gradient using this formula, y2 minus y1 upon x2 minus x1. We will take any 2 points and find the gradient. It's better to take the points which are more far apart. That will give you a better approximation because this is approximating. And you can either find the gradient, you can either find the y-intercept by just looking where it cuts the line. Because I've not drawn this on a graph, this is not very accurate. But to find a more accurate way, you can put the one coordinates into the equation. You can put the gradient and you will find the value of the y-intercept. So this is how you can plot non-linear equations by using linear law. And you can find the gradient and the y-intercept. So this was a very small chapter. You will have to do a lot of questions for this. Most of the chapter is just about making the non-linear equation into a linear equation. Y is equals to mx plus c. You just have to replace y and x by other non-linear variables. So that was all. Thank you for watching. Goodbye.